Okay, let's get started. Very good morning, all. I hope you were able to complete yesterday's tasks that I had given you to read about NAT instances, and NAT gateway. All right. So let's get started with today's session. So today is going to be an important session on EBS. Okay, it's one part of the EC2. Where EBS is basically a block storage. So let's get started with that. Just give me a second. Let me pull up my screen. Okay, I'm here. So let's first look at what is the product documentation of EBS, right? Yeah. Okay. So EBS is basically, as the name says, it's called Amazon Elastic Block Store. Okay. So now you need to understand what are the different types of storage that systems or computer systems use, right? So one is called block storage. I mean, it's very synonymous to the hard disk that you use, correct? I mean, the hard disk, I mean, all of us use a laptop or a desktop and it has a hard disk in it, right? And there are different types of hard disks. It can be a magnetic disk, or off late, you get flash based, all flash based, disks such as SSD volumes and so on and so forth, right? So, so that's one type of, underlying storage that you can have, which makes use of file system, some sort of a file system, and it can basically present a volume to the operating system. Volume is nothing but your C drive or E drive, right? Or one of the devices that you mount onto Linux. So that's called a block storage. Because why is it called block? Because it's a full block, right? And if you take a 8 GB or 80 GB volume, I mean, it will be a full block volume, right? So that block will have some sort of a file system in it. And, when the operating system reads from the block, it will have some sort of a table which it looks up, right? So which sector it has to read, and then it basically goes to that sector and reads the files, the data from that particular sector, right? That's why it's called a block storage, right? So in this case, you take any virtual machine. So virtual machine is supposed to have some sort of underlying storage, correct? I mean, it can be a C drive, D drive, or it can have a slash, which is the root, slash data, which can be the an additional data volume that you can attach to an EC2 instance, right? So at the end of the day, an EC2 instance is nothing but, I mean, it's a virtual machine, right? So obviously, virtual machine should have some sort of storage attached to it, where it can store the operating system files plus the other files that it generates, right? So from that perspective, you have EBS as the service that AWS offers, and EBS is very, very it's a very I would say efficient service, and there are different types of EBS volumes that AWS offers to match different performance parameters. Like even when you go and buy a desktop, right, you can actually choose whether you want to go for a magnetic drive, magnetic hard disk, or you want to go for an SSD, correct? So similarly, when you buy server class machines, the underlying storage that comes with it, right? So you can actually choose, right? So what kind of storage do you need, right? But usually what happens is in large scale, data centers, the storage that is attached to that server will not be used, right? So because that's kind of redundant, right? So they don't use that, or obsolete. They don't use that. We don't use that. Rather, what we do is there's something called SAN, right? Storage Area Network, right? So again, you can read more about SAN. So SAN is called storage area network, where it is a set of arrays which has storage devices, which will be connected to your compute environment, right? So through high performance, fiber optic cables, right? So that's called HBAs. And then eventually, if your server needs, say, a 80 GB volume attached to it, it will be created from that SAN, which is a separate network altogether, and it will be presented to the server, and the server will mount that block onto itself, right? So that's how it happens. In AWS also, it's a very similar thing that happens, right? So there are two types of storage that can come, right? So one is called in EBS, where it's equivalent to the SAN, and where there's a huge array of disks and huge array of storage which is available for EC2 instances, and you can go provision whatever, right? 8 GB, 80 GB, depending on your performance requirements. And there are different types of EBS volume types that are available, such as general purpose. And if you need additional performance, then you can go for a IO1, IO2. So then you provision that, and then you attach it to the EC2 instance, right? So that's the way it works. That is the first type of storage. Second type of storage is there's something called ephemeral storage. So now when you provision an EC2 instance, that EC2 instance will sit in one of the physical host in the data center, right? Like the video that you have seen. So now inside that physical host also comes with a local hard disk. Okay, but the problem with using local hard disk is, when your physical hardware dies, right? Because that's one single host, correct? I mean, if that host dies, then you will also have a loss of data, right? And you will also lose your virtual machine because there's no backup for that, right? Whereas if you provision it from EBS, there's an SLA associated with EBS, because what EBS does is it's an array of storage disks. So that way, I'm not sure how many of you know what a RAID configuration is, RAID, but you can read more about it. So now it uses some sort of a RAID configuration where it makes your storage very redundant, right? And it will store copies of your data across multiple different disks, so that one disk failure in the array does not impact your data availability, right? So that's the way it works. So that way, EBS is designed for high availability, fault tolerance, and resilience, right? And data durability. Whereas if you go for an ephemeral, which is attached to that local EC2 instance, it's a local host of the EC2 instance. So now local host, that physical host can fail anytime. So if you provision something and if you store something as the ephemeral, then it's bound to lose, right? So that's basically the difference. But EBS is not that, right? EBS is a centralized storage which is managed and which provides you resilience, fault tolerance, and availability and durability. Okay, so that's where EBS comes in. So let's quickly read more about EBS. So EBS is like your hard disk, right? So, but it's a advanced version of your hard disk. It's not just a simple hard disk. Hello. Just to go on mute, please.
Samad, can you mute too?
Yeah, I've muted. Okay, so Elastic Block Store provides a block level storage volumes for use with EC2 instances. EBS volumes behave like raw unformatted block devices, right? So when you assemble a computer of your own, right, and when you buy a new hard disk from Amazon or from a shop, so it will be completely raw. It will be unformatted, right? So you can use any file system to format that device and use it, right? And then you can mount these volumes as a device on your instances. EBS volumes that are attached to an instance are exposed as storage volumes that persist independently from the life of the instance. You can create a file system on top of these volumes or use them in any way you would use a block device such as hard drive. You can dynamically change the configuration of a volume attached to an instance. Okay, so you can actually detach a volume from one instance and attach it to some other instance, right? So now, just remember that EBS volume is like your hard disk, but it's more than hard disk, where it provides you a better data durability and better high availability and so on and so forth. And you can use it when you want data that is quickly accessible and requires long-term persistence, right? And 99.9% of the time when you provision an EC2 instance, you would provision an Ebs volume as well. Okay, there are very, very remote situations where you go with a local storage, which is the ephemeral storage, which comes along with the physical host of the EC2 instance. Okay, which is probably not used, and there are some use cases for that. Let's not get into that. Don't get confused with it. Ebs is like SAN on the cloud, right? SAN, which is what is SAN? SAN is storage area network. Yeah, you can read more about this in the Wikipedia article. What is a SAN? Okay, as I said, SAN is an array of servers which has storage in it, and it connects to the compute environment using a fiber optic channel, which is a high-speed fiber optic channel, which delivers a very high throughput of data transfer between the SAN and the compute devices, right? So that's where, and also you need some sort of host bus HBA, it's called HBA card. So this is the card which will translate, which will enable you, where you actually use it to, interact with the SAN devices. It's very interesting. Read about it. I mean, if you kind of know these terminologies, it will be very simple, and you will be able to, convince the interviewer or convince the person in a very, confident fashion, right? So that, yeah, Ebs is like SAN on the cloud. Okay, Ebs, you can create a volume in a specific availability zone and attach it to an instance in the same availability zone, right? To make a volume available outside of an AV, you can create a snapshot and restore the snapshot to a new volume. Snapshot is like a photocopy, right? So you just take a photocopy of that whole Ebs volume, and then you can take that copy anywhere in that region, right? You can just share it with any other availability zone and use it. And Ebs provides multiple different types, right? So general purpose SSD. Okay, SSD is solid state drive, right? So how many of you know what an SSD is or using an SSD? Can you guys, one of you unmute and say what, if you've used an SSD?
Is it for performance of the SSD will be very high?
No, come again.
The performance of the SSD will be very high, like when we open anything on our computer. So it will be responding very quickly.
Okay, why is it high? Yeah, why is it high?
Sir, basically, SSD is built on FETs, sir. It doesn't have any optical drive. It occupies very less space as compared to the traditional hard disk drives. And since it is made up of transistors, the switching speed is very high.
Okay, very good. So basically, if you take a traditional hard disk, right, which is called a magnetic hard disk, the magnetic hard disk will have a physical disk and it will have a head, right, a read-write head, and it will have a small motor attached to it, right? So now there's the disk will be rotating continuously, right? Let's say 5,000 RPMs rotations per minute, or 7,000 or 15,000 rotations per minute. So now, depending on the operating system's command to retrieve the data from the disk, what the hard disk does is it basically places the read-write head on top of the sector, and then it reads that sector from the disk, right, while it is rotating at a very high speed. So now at the end of the day, it's a mechanical operation, so which means that it may, it may wear out over a period of time, right? So, because mechanical parts can have, wear and tear, unlike electronic parts. And on top of it, it will have some sort of, overhead in terms of the speed that it can deliver, right? So because maximum, it can rotate up to like 15,000 rotations per minute, right? So, and common hard disks that we use at home is like 5,000 to 7,000 rotations per minute. Server class, it rotates up to 15,000. So now because of that, you will have different speeds, and it will impact the performance. Whereas all of you would have used pen drives, correct? Pen drives are very fast, right? So pen drives have no mechanical parts in it. It's just a chip inside, which has got some transistors which will hold the data, and then it will basically, you just plug it into an USB, and then it can transfer data at a very high speed, correct? So now imagine SSD as something like a flash drive, but a large flash drive. Okay, it does not have any mechanical parts. All that it has is only chips inside. Okay, it's called flash memory, and you can store into the SSD using some special drivers for SSD. So that way it provides you a very high speed, and it provides you better performance, right? So that's where if you see the general purpose SSD, there are two codes that is available, GP2 and GP3. It provides you a better price and performance for a wide variety of transactional workloads. These volumes are ideal for use cases such as boot volumes, medium size, single instance databases, and dev test environments. Okay. And similarly, there is also a high performance SSD, because so now usually what happens is in storage, right? So the storage is measured by IO per second. Okay, like how CPU is measured, right? Like CPU is measured by the instructions that it can execute in within the time, right? So similarly, and also the utilization of CPU. Whereas in disk, it is IO per second, right? So how many input-output operations that it can perform in every second. Okay, that's the way disk performance is measured, right? So now if you want a disk that can perform, say, 10,000 input-output operations per second, which means that it can either be a read or it can be a write. Okay, if every second, if it needs to perform, say, 10,000 operations, imagine an application which is using a database which is very, very busy, and so much of read-write operations that happens on the database, right? So the underlying disk also has to support the database, right? Otherwise, your database will not be able to perform well, right? So from that perspective, you need a better IOPS. It's called IOPS, IOPS. Okay. So now you can determine if your disk needs a better IOPS, say it needs 12,000 IOPS or 20,000 IOPS, then you'll have to go for IO1, IO2, where you can specify that I need 20,000 IOPS. Whereas in GP2, GP3, you can't specify, like for example, per GB of GP2 volume or GP3 volume that you provision, you will get 3 IOPS as a standard performance, right? If you're provisioning a 100 GB volume, so then you get a 300 IOPS. Okay, so the performance will be limited within the 300 IOPS of operations that it can perform. That is the reason they say that it is ideal for use cases such as boot volumes, medium-sized single instance databases, and you can use it for development and test purposes. Whereas if you're really up to a serious production workload, which is going to have a very demanding need in terms of input-output capabilities, so then you'll have to go for IO1, IO2, where it can scale tens of thousands of IOPS per instance. Okay, and also there's also a HDD, right? Hard disk magnetic drive, like how you have for your laptops or desktops. If you have a magnetic drive, you can also go for a magnetic drive, which will be low cost, right? If you really feel that, for your workload or for your application, you don't need a GP2 or an IO1, IO2, you can go for ST1, which is the magnetic drive, which basically gives you throughput rather than IOPS, right? So because usually SSD is defined as IOPS, whereas magnetic is defined as throughput, right? How much data it can transfer per second, right? It is defined in Mbps, megabytes per second. Okay, so that's where if it is sequential, right? So because usually the way it works well is if you have a sequential, right? So you have a movie stored on your hard disk, and you're playing that movie will be played sequentially, right? So because that whole movie file of whatever 1 GB, 2 GB will be stored in a sequential format, and it can actually play it very well. But if it is a random IOPS, right, where if it's random reads or writes, so it has to randomly read from multiple different sectors, from multiple different volumes. So then it really doesn't help in that cases, right? So you'll have to basically go with the GPU2, GP3 or IO1, IO2. You can also encrypt an EBS volume, right? And you can monitor the performance such as bandwidth, throughput, latency, average queue length, all of that using CloudWatch metrics, right? So CloudWatch is like a monitoring for cloud. Okay, so this is the basic, introduction to EBS. Right? As I said, there are different kinds of EBS volumes. Now let's get back to our lab. So now when I provision an EC2 instance, I go to my EC2 and I go to launch instance and I use Amazon Linux 2 and I choose t2.micro and I say next configure instance details. I'll provision it in my public subnet, add storage. Okay, so now when you are on the storage page, you will see this, right? So if you see this, what is the volume type? It's root. Root is nothing but your volume that contains your operating system, the files that are needed for your operating system. It's like a C drive in your Windows. And this is the device path. Forget about snapshot for now. Size, you can give a size here, right? I want 8 GB or I want 10 GB or 100 GB, right? You can choose, but go for 8 GB because 8 GB comes under your free tier. Okay, if you cross 8 GB, then remember you are going to get charged. Okay, so then comes the volume type. So here you can select whether you want a GP2, GP3, which is general purpose, or you want a provisioned IOPS SSD, which is basically your where you can define, right, how much IOPS you need, right? So for example, for this 8 GB, so you want 1000 IOPS, right? So because you expect that, the files within this are going to be read and written, at a very high velocity. So then you need a better IOPS, then you can go for 1000 IOPS, right? Or you can go for IO2. There's a small difference between IO and IO2. You can read about it. But for now, just understand that GP2, GP3 are general purpose. If you need to control the input-output operations per second in your own way, then you have to go for IO1, IO2. But it comes with the price, right? So the price of IO1 is going to be much higher than a GP2, GP3, right? If you go for GP2, as I said, if I need just 8 GB, right? Then it comes with 3 IOPS per GB. Okay, so that way, the minimum IOPS that it provides is like 100 IOPS, right, irrespective of the size. But if you go beyond, say, for example, like if you go for a say 20 GB hard disk or 20 GB SSD, then you could get 160 IOPS, right? So for example, if I just make this 20, okay, so then you will get a 20 into 3. Okay, it's 60. So let me make it say 50. Okay, so if I make it 50 GB, so then you get 5 3s are 15, right? So you get 150 IOPS by default. Sorry, just give me a second. Yeah, so that's where, right? So if I provision a 50 GB volume, right? So then it gives me 150 IOPS, right? So maximum it can go up to 3000 IOPS. Okay. So anyways, I'm just going to go for 8 GB, right? And then if I want to select an encryption or not, I can do it. If I want to say delete on termination, I can check this. So when the EC2 instance deletes, this volume will also go away along with the EC2 instance. If you don't check this, then you have to go manually select that volume and then delete it from the console. And you may forget to delete it, which may lead to additional charges. Okay, so now let me just go to add tags. Just I'll say name EBS lab. And then you can add this tag to instances. You can add the same tag to volumes and the network interfaces also. So even the volume will be tagged with this. When I say volume, the EBS volume, right? I use an existing security group, public. Yeah, I'll go for this. Review and launch. Launch, I will use my KP, PEM, acknowledge launch instances. Okay, so let us bring up the EC2 instance. In a while, let me just come back. Just give me a second. Let me pull my screen back. I'm just trying to. Okay, let me pull my screen back. The instance is provisioned. All right, so it's provisioned, it's running. So now if I select this, and if I go to storage here, the EC2, so you will see how many volumes are attached to my EC2 instance. So this is the volume ID, the EBS volume ID. This is the name of the device. This is the size, and this is the status of attached, right? And so on and so forth, right? So it will just give you that. So now on the EC2 console, on the left side, you will see this elastic block store, right? So you can, let's play around with that. So if I click on volumes, clear all the filters. So you will see all the volumes that are provisioned in this particular VPC or in this particular account. Okay. So now if you see here, EBS lab is the volume that we provision, which is the root volume, which is 8 GB. And it delivers a minimum of 100 IOPS. If I increase it to say 50 GB, then it makes 150 IOPS, because always remember GP2 provides 3 IOPS per GB of data that you provision or volume that you provision. And then what happens is it provides you some other details. Snapshots will come back later, don't get, and then it will tell you which instance it is attached with, what is the attachment status, encryption status, and so on and so forth. Okay. And also in the bottom pane, you will see some status checks. Okay, it does a continuous status checks of it to see the health of, or to monitor the health of the volume. So then it also has some monitoring metrics associated with it, such as how much read bandwidth, how much write bandwidth, how much read throughput in terms of IOPS, write throughput in terms of IOPS is spent, and all of that, right? So it will just do all of this. And then it's kind of given, right? So now let's log into that EC2 instance. Right? I'll use the same key, but I'll go to the EC2 instance. And what is the, let me grab the public IP address. Okay. Yeah, so I'm connected to this, right? So now, if it is Windows, it's pretty straightforward, right? I mean, in Windows, once you provision something, you can see you can go to the, the storage manager or something like that, right? And then you can see the volume that is attached to your operating system, to your virtual machine, right? Whereas in Linux, you have to use a few commands, right? You have to use commands like lsblk, right? When you type lsblk, it will tell you, how many volumes are attached to your Linux instance. So it will tell you, right? So it is slash, right? So there's an 8 GB volume that is attached to my Ec2 instance, which is called xvda, and then it's mounted on slash, which is the root. Okay, so it's mounted on the root, so you can just understand from that. And if you want to say attach and all that you see, right, ls-l. So if I go to my root volume cd slash and say ls-l, you see all these files. This is all stored in the root volume, which is like C drive for Windows, right? But Linux, slash is your root C drive. It's called always root. Okay, so now all these files are actually stored on the DBS volume, right? And which is the DBS volume? So this is the DBS volume. Okay, this is the DBS volume, which has a 8 GB, and then you can kind of perform some actions such as you can detach this volume from that Ec2 instance. So then immediately, Ec2 instance will become a little unusable. Not little, it will be unusable. And you can create a snapshot. We'll come back to that later. And then you can also modify. You can increase it from 8 GB to, say, for example, I want 20 GB, right? I can just make it 20 GB. Let's say just modify, but it'll take a while to complete. Okay, it'll go ahead and request for that increase in size. Okay, so now it has done. It has already done that increase in size. So now it's at 20 GB, right? So it's modifying it if you see here, right? 0%, 5%. It's actually optimizing it. Anyways, it's modified. So if I go back and do an lsblk command, lsblk, you will see that it is 20 GB. Okay. So out of 20 GB, 8 GB is allocated to the root. So now you have remaining 12 GB that you can make use of, right? You can create a new partition out of that whole 20 GB. Like Windows guys, you would have done it, right? Like on your laptops or desktops, you have 80 GB, you would have given 20 GB to C drive, you would have given 40 GB to D drive, right? Another 20 GB to your E drive, something like that, correct? So similarly, 20 GB is available. I can just split that 20 GB into multiple chunks and I can mount it on different drives, right? With different drive letters. So that's the way you go ahead and modify it, and it gives you, and you can also kind of modify this. Okay, it's already modifying it, but I just wanted to show you, how to modify it further. You can change it from, say, GP2 to IO1 and things like that. You can do that. So yeah, so it'll change in a while, right? I mean, right now it's optimizing. So what it does is behind the scenes, it creates a new thing and it copies over the data and it does all of that. So anyways, I mean, all that is like transparent to the end user. You don't have to worry about it. Okay, so now if I need to attach a new volume to my Ec2 instance, right? So how do I attach? I've got a set of steps that I want you to follow today, right? So these are some steps, and you can go create a volume from the from your volumes, right? So you can just go. Right now it is at 20 GB. So I want to attach additional 20 GB of GP2. I will just go to create volume and say 20 GB. And choose the availability zone as the same availability zone as your Ec2 instance. Remember, availability zones are physical locations, physical data centers, right? So use the same availability zone and add a tag as name, EBS lab, and give data volume. Right? So give the name as this, Yeah, data volume, right? So just give that. Say create volume. So it's created. It's in the creating state right now. Yeah, it's available now, right? So it's available. So now what you can do is you can go to the public EC2 instance that you created, right? You can go to the public EC2 instance, and here from here you can go to actions and attach volume. Okay, actions, images and templates. Sorry, one sec. No, you can go back to your volumes and select that new volume that you just created. Go to actions and attach the volume from here, right? So when you say attach the volume from here, it will ask you which instance that it needs to be attached, right? So this is the EC2 instance, the public EC2 instance that is running. So you select that, and it will by default give a device name. You can just retain it as it is, right? And then say attach volume. That's it. It's attached. Right? If you see here, if I select this, it will change from available to in use. The status would have changed from availability to in use, and it will also show which instance that it is attached to. Okay. So now it's attached to the EC2 instance. So now it says it is attached already. So you can go to the EC2 instance, and here just refresh it. Select the EC2 instance, go to storage, and you will see 2 volumes attached to your EC2 instance. Okay, so now let me come back to my EC2 instance and again do lsblk. Okay, so you will see that there's 120 GB which is attached, out of which one partition is 8 GB of your root. And there's one more xvdf which is attached to your EC2 instance. But how do I make it usable in my EC2 instance? If it is Windows, what you do is you go to the storage manager, right, or disk manager, and you will see that new disk which is available, and you can right click that and you can say create partition, and you can format that partition and give a drive letter to it, right? All you can do it through the GUI itself. But here in Linux, you have some commands that you need to execute, right? I have given all those commands out here. Okay. So now what you have to do is you have to use sudo, right? So, okay, in Linux, I think I did not mention you this. So now, right now I'm logged in as a EC2 user, right? So whenever I want to perform some admin related functions which requires higher privileges, I need to go for sudo, right? Sudo is nothing but it's a super user, right? You have to use sudo, right? And then type the remaining command, right? So now let me just do lsblk. Okay, so now in lsblk, I can see the drive name, right? So which is xvdf, the new volume that is attached. It's called xvdf. So the other one is xvda. This is xvdf. And then what you have to do is you have to say sudo and file -f/dev/xvdf, right? Again, /dev/xvdf is nothing but this is the device, right? And xvdf is the new disk that is attached to this device. Okay. So you can just say /file-s/dev/xvdf. Okay. So what the file command does is it basically creates a file system. Okay, using the /dev/xvdf, using the new volume that you created. Okay. Again, just say it's available. So now what you need to do is you have created a new file system. So now you also have to format that file system, right? So now that's where you have to use mkfs. Okay, you have to format that file system using the type xfs. Okay, that's the file system that Linux uses. So you can run this command sudo mkfs-t xfs/dev/xvdf, right? And again, this xvdf has to come from the lsblk command. Okay, you have to use the lsblk command. Okay, to find the right name, right? So because these names can change. Okay, so now you can do sudo mkfs, run this command. Okay, so the file system is created. So now what you do is you can create a new folder. Okay, so now what you can do is now what you've done is you've basically created a new file system. You've formatted that file system called XVDF. So now you have to assign a drive letter to it, right? In Windows, you go and assign a drive letter. But here, what you do is you mount that volume onto a path. Okay, that is what you do in Linux. Okay, so only then you'll be able to see that. Okay, so now you want to see how many volumes are attached to it, right? Or how many drives are attached to it. You can see it from here. If you give df, right? Df minus dh hyphen dh. So you will see that this is the root volume. So these are all some system volumes that it has, right? So /dev is your device volume, right? So now you have only 8 GB which is attached right now, which is used, and out of which 19% is used, and remaining 81% is free. Okay, so now when we mount the new drive that is created, right? The new drive which is formatted, which is XVDF, which is a data volume. So what you need to do is you need to actually create a folder called mkdir data under root, right? So when you sudo mkdir data, because you need higher privileges, right? So now if you see there's a new data directory that is created. So now what we are going to do is we are going to mount that new volume onto this folder called data. It's just any name. It can be any name. Okay, we're going to mount it on this particular, mount point. So this is called a mount point actually, right? So you basically mount that new volume that you created to this. So in order to mount it, you have to use this command. Sudo mount /dev/xvdf to /data. Okay, so mount is the command. What do we want to mount? We want to mount /dev/xvdf. So that's the new volume which is created. And where do you want to mount it? You want to mount it at /data. That is the mount point. Okay, so now it's mounted. So now you can actually go to cd/data and you can start creating files, right? So you can actually start creating use nano and say myfile.txt and say this is my file attached to the new EBS volume 2. I will save it. Yes. Okay. Okay, so you'll have to probably use mount. I'm right now as root, right? So you should say sudo nano myfile.txt. This is a new file that is created in the new EBS volume provisioned. I will save it. Say yes. Yeah, it is saved. ls-l, the new file is also created. It is created in the second EBS volume that is attached to your Ec2 instance, which is this EBS volume, not to this volume. So these are two physical separate volumes. It is now present in this volume. Okay, use sudo, right? Use sudo if you don't have privileges. Okay, so now see, these commands may seem a bit overwhelming, but practice it a couple of times and then you can do it. So I'm not going to ask you to create a 30 GB volume. So instead you can just create a 8 GB volume. Yeah, you click on create volume and give the size as 8 GB, right? As 8 GB and not 30 GB. Okay, you have to give the size as 8 GB and not 30 GB, and then follow these steps. So then once you are in, right, so you'll be able to follow these commands that I have given, right? So the first command, it checks the file system. Okay, if you give sudo file -s/dev/xvdf, if you want to see, you can actually go to cd/dev and say ls-l. So you will see here xvda is the it's the primary root disk, right? XVDA is the root volume. XVDF is the new one that is given. Is the new, volume that we just created. So you can just even go from dev. It will have all the devices that is attached to the EC2 instance. Okay, so now when we say file-f/dev/xvdf, it will tell you what is the file system, right? In this case, a new file system is created and formatted using SGI XFS file system. Right? So that's, and what is the block size? It's 4096 bytes, and that's the block size that it has. Okay, 4096 KB, sorry. And then it is mounted. Then you are basically creating a new file system here. Okay, MKFS is make file system. That's the command. Okay, you're creating a new file system. And here, the red one, you have to always remember, you have to take it from the lsblk command. You do lsblk, whatever name that you see here for the new volume that you created, use that. It may change as well, right? It may be xvd d, right? It can be anything. So instead, just don't go by what I've given, right? Just go by this thing and then use the same in all of these places, right? So this also, you have to use it from the output of the lsblk command. So then go to root, create a new folder called /data. And then here you're mounting that XVDF, the new volume, to the data. And you can go to navigate to /data and you create a new file. Use nano editor, right? So the command is sudo nano file1.txt. Okay, so then type some text and press Control X. Okay, press Control X and give confirmation as yes, Y, to save and exit. So then the file will be created. Check the file created using ls-l command, and it will list the file. Okay, so now this is basically the assignment that I want all of you to do. But before that, read this, right, and go through the the product documentation. Just read all of this, and then what you can do is you can complete this assignment for today. We can actually do the snapshots tomorrow. Right? So snapshot is another interesting topic, but it will take a while, right? So, but you can just do this for today. And I'm going to delete the snapshots from the today's exercise so that you don't get confused. So then you can clean up all of this, right? So then, okay. So the last thing that you need to do is, see now, when you create a new volume, right? Or when you go to the EC2 instance and when you see the storage and the EBS volumes, delete on termination, the root will be like yes, but the other one will be no. So now I'm going to delete my EC2 instance. So let me just go terminate my EC2 instance. Okay, it's getting deleted. So let's wait for it to complete termination. Okay, let me go to the volumes and refresh the volumes. You will see that one volume has gone, the root volume, right, which got created by default during the EC2 instance creation, that is deleted now. So now only the data volume, which is the 20 GB, which is available. And if you don't delete it, you will get charges, right? So what you need to do is you have to go to actions and delete this volume manually and say delete. Yeah, so now it's deleted. So now you're free of any additional charges. It's terminated. Okay, so what I'm going to give is first is terminate the EC2 instance. Go to EC2 console, Ebs volumes, select the new data volume created. Okay, click on actions, and delete volume. Okay, so this is the assignment that I want all of you to do, but more importantly, just read these topics. Okay, go through the each instance type or each Ebs volume type that you have, right? And then you can basically complete this lab and use only an 8 GB volume and then clean it up, right? Even if you by mistake create a 30 GB volume, no problem. You'll be within the limits because it's the way EBS is built is very interesting. So go to calculator.aws. I'll create an estimate. I will say EBS, Elastic Block Store. So now here, if I select number of volumes is 1, and how many hours that it runs is like 730 hours. It's the GP2. Okay, I'll just know snapshot usage. So it's a 30 GB volume. So for a 30 GB volume per month, you will incur about $3.4. Okay, it is actually 30 GB into 0.114 US dollar, which is per instance month. Okay, that's the way it is charged. So now the way EBS is EBS pricing. See, in free tier, what you get is go to Mumbai, Asia Pacific, Mumbai. Where is Mumbai? Mumbai. It's here. Okay, the way it is. If you go for a GP2 volumes, it is 0.114 per GB month of provision storage. Okay, which means that if you provision say 1 GB and if you run it for a full month, okay, if you run it for a full month, let us see what is the price. I will provision say 1 GB, and if I run it for 1 full month, okay, I'm going to incur 0.11 US dollar for that 1 full month. If you delete it, right, so after 1 hour, right, so after 2 hours, if you delete it, then you will be prorated for that 2 hours, not for the 730 hours. Right? Because it's usually 730 hours in a month, right? It's not for that 730 hours, but you will be prorated for that 1 hour. So this will change, right? So in this case, it is 730 by 730, right? So which is like 1 instance month. Instead, I have only used it, say, for 10 hours, right? So then it is 10 by 730. How much is 10 by 730? It is 0.0136, right? Which is 0.0136. So which means that 1 GB into 0.0136 into 0.114, which is you will be charged $0.001554. Okay, that's the way it works. Okay, so if you see this is for the entire month, right? So I'm not going to use it for entire month. Rather, I'm going to use it for say 10 hours. So then it's pretty much, I mean, it's so negligible. But anyways, if you go back here, the free tier offers up to 30 GB of storage, 2 million IOPS, and 1 GB of snapshot storage. Okay, so that's what is the free tier. So as long as we are within the 30 GB, you're safe and you're good. Okay, so what I'm going to do is I'm going to share this assignment with you today, right? So today we are wrapping up the class a bit early, due to some work that I have to step out on an urgent need. I'm going to give this and read about the concepts that I just mentioned in today's class and do this lab exercise. And we can continue with snapshots tomorrow and complete EBS by tomorrow, and possibly take an additional topic as well. So I've just shared it with everyone. It's there in the chat. So please download it from there and please read the concepts and do this lab exercise. Okay, and people who have missed it, please ask them to read through this or watch the video for today. Right, and if you have any doubts, we'll clarify those doubts tomorrow. And in case if you need to kind of revisit something, maybe you can watch this video later once it's available.
Okay.
Sure, Anna. Thanks, Anna.
Okay, thanks everyone. Thanks, Krishna. Thanks, Mentor Sairam. And have a great day. I'll see you all tomorrow.
Yeah, thank you so much.
And let's continue with our EBS, and let's close our EBS tomorrow and start with a new topic by tomorrow. Okay, all right. Thank you. Have a great day. Bye. Sairam.
Thanks, Anna. Bye, Anna. Sairam.
Bye.
Hello, guys. Yep. So we had little, important commitment, so we had to close it within 1 hour. Just making sure you guys are all clear up to the mark, and up to the date. Make sure if you guys have any questions, I'm just repeating the statement from yesterday. So if you guys have any questions from previous sessions, right? So please do get clarified by your mentors. Do not hold on to further sessions because you will not be able to catch up with the flow again. And we have decent time today. If you guys have any questions, yesterday there were a couple students who needed help with their EC2 and also putty setups, right? So make sure you finish everything in today's class, since we have extra 30 minutes. And I'll just open the breakout rooms now. If you guys have any questions for the mentors, please do let us know. Yes, everyone join the breakout rooms now.